Okay, since we're done with the acquisition mode, now next we're talking about like once you're done with taking the image, we want to do some like simple analysis. Usually you can use either ImageJ or other analysis program to do whether it's the allocation or some kind of histogram analysis. So what you can do there all can be done here on the XAMPP software too. So for example, let's look at this image. This image, we have the green, the orange dye and the green dye we are having here. So you can notice that basically these two dyes are standing at the different stuff. So they are kind of out of focus. So if we want to look at the intensity of the dye, we can just hit here the histogram. So at the histogram here, it is telling you like the information about each fluorescence channel. So for example, the orange channel we are in this image here, the average intensity is showing to be 905 arbitrary unit. And for the green is around like 29. And the standard deviation is shown here. Median is shown here. So for this is the very like basic exploratory data analysis. So, but if we want to, for example, we can notice there's some like black dot that is the background. We don't want to see it. Let's just increase the threshold to exclude out the pure black background part. Then we can look at the again at the fluorescence average intensity and the medium that is more close. In like data analysis is like the get rid of the zeros. Okay. And we can also do, for example, here, draw a square to look at the certain area we want to see. Once you click the draw, you'll notice that the average intensity is changing because they are only calculating within this square. Okay. And here is the histogram chart. You can adjust the bin and the upper limit to have a better look at the histogram of the pixel intensities. And for example, if we know that the green and orange channel are very like out of focus, they are not colocalized. So we can also use this colocalization tab to see if they're how colocalized they are. So here you can see the chart for the colocalization analysis. 1, 2, 3, 4 or response to 4 is the background, 3 is the colocalization. So let's take a look at the colocalized part. And we can set the threshold here, adjusting manually, or they can do like they can do auto setup. So do here. This thresholding is you can see if I go down by the threshold for the vertical, which is the green channel, you can notice the pink dot here. This is the place that is they define as colocalized. So colocalization calculation is also very like intensity dependence analysis. So when you are trying, this can tell you the overlapping of the of two dies, but when you use it, you really need to understand what you are looking at and how you interpretate the data. So let me go back to AutoSet. And here we can click the table here. It will show you the colocalization, the Pearson value for colocalization, which is 0, which is good because in our case, the orange and green should not be colocalized. Pretty good. And Mender is another analysis way for colocalization. When we are doing colocalization analysis, these two, we need to look at them together. You cannot just say that, oh, the Pearson value is really good, so they are not colocalized, or they are colocalized, because there's a very extreme situation, very extreme cases that will have very good Pearson value, but they are not colocalized at the same time. So this is the basic EDA for you to analyze the images. And I have the Python code to do all the post analysis that is in the package I'm sending to Dr. Berg. And if you are interested, you can look into it. And that will be all for this videos. Thank you.